So here we're looking at the recursive binary search. Now, the recursive binary search is sometimes referred to as a divide and conquer search algorithm because essentially each time it runs the search, it eliminates 50% of the search area. Now, one requirement, or we call it a precondition of the binary search, the recursive binary search, is that we need to sort the array in ascending order. So if we have a look at the array here on line number 42, you can see that it's sorted in ascending order. Okay, so just amending that a touch. Okay, so now let's just have a look. First and foremost, on line 16, we have the method header. And down here, lines 40 plus, we have the main method. In the main method, line 42, we have our array, and it's got 8 elements. Lines number 43, we have the array which has been called, and we are assigning the result of the recursive binary search method to the found index. Okay, found index on line 44 is simply plugged in next to the string literal. 12 was found at index and found index. If the value is found, okay, it will return the index position. If it's not found, it will return -1. Now let's get into this. So on line number 16, let's imagine we're looking for 12. We have our header, method header, public, that's our access. Static means that if we're running this method, we do not need a object to run it with. We can run it freestanding as we have done so here. Okay, the method returns an integer value, okay, e.g. -1, or the position which it finds the search for value in the target. Then we have our method header, which is recursive binary search. Now the arguments, there are 4 arguments in our parameters. The first one is our array, and if we look here in the main method, you can see we've plugged in our array. The target value, which is 12. Okay, the starting point, which is where we intend to start our recursive binary search. Usually this will be 0, but sometimes people may want to search from a specific position onwards. Okay, and we have our endpoint, which is essentially the array length. Now, and that will obviously vary each recursive call. Now, on line number 18, we start off with defining the middle point, because if we're dividing essentially our search for area, each time we start off at we find locate our middle point, and then we say, okay, is our element less than or greater than this area? If it's less than, then we know that we need to search in the lower half. If it's greater than, then we know we need to search in the upper half. So what happens here? We define our middle position by saying start plus end, which in this case will be 0 plus 8, which is our array length. Okay, then we divide that by 2, which will give us the value 4. Okay, now once we have this value, we come down here and we say, okay, is this position, so our middle point, now let's imagine in this array, it's going to be 0, 1, 2, 3, and 4. And what we're essentially saying is our value 22, okay, the same as our target value, or is our target value the same as 22? Obviously, we know that's not the case, so we say false. If it was true, then we'd just return the middle position. So now we come down to our base case check. Now you may be thinking, okay, why is the base case actually not first, not above this item here? Well, if we only had one element in the array, then the base case, which is end and start being the same position, would return -1 automatically. So we firstly check essentially our first cycle of our array. Okay, and if it's one element, then it will return the middle immediately. If it's greater than one element, then it will proceed as we are. So here we say if end is less than start, then return -1. So this is the base case statement, basically checking if we have elements still to review. Then we have our first recursive call. Now this recursive call is looking at the start to middle, so that's essentially in this case would be in this area. Okay, and the second recursive call looks from the middle, which will be here, and up to this area. Okay, so we're now trying to shorten our search area by saying, okay, is it in the upper half or the lower half? So if we look at the code on line 28, it says if target, now our target is 12 if we remember, if 12 is less than array middle. So is 12 less than 22? Yes, it is. So that means that this statement is of course true. So we need to proceed to the body. Okay, now what does the body say? It returns the recursive binary search again. Now we need to plug the new values into our recursive search. So obviously the first value ARR, which is our array, is the same. Our target value is the same. And our start position, of course, is going to be the same because we're looking at the lower half. Okay, so that's still 0. Okay, and our end position has now become middle -1 because obviously we've checked if our value was equal to 22 and we know it's not equal to 22, so it's going to be middle -1, which is going to give us this position. So 0, 1, 2, 3, so that's position 3. Okay, so these are the values that we plug into our new recursive search. I'll just make that a recursive search with its new values. So then if you can imagine, we go through the cycle again, plug in our array, our target the same thing. We're looking from position 0 to position 3, which is like here, 0, 1, 2, and 3. And what are we saying? We're saying let's halve it again. So if we halve 0 to 3, okay, now if you remember, we are doing integer arithmetic here. Okay, so if we halve 0 plus 3, okay, because that's our start position plus our end position, so 0 plus 3, and we get obviously 3, and we divide 3 by 2. Now again, we said it's integer arithmetic, so that would obviously return the value 1. Okay, and we look at our position 1, which is our middle, 0, 1, and we say, okay, is our target the same as our array middle? So is our target 12 the same as our middle position, which is our number 7 here? Okay, now we know that the target is not the same as 7, so again we return a false value here. Okay, then we come down to our if end is less than start. Now is 0 less than, if end is less than start, sorry, is 3 less than 0? No, it's not, so again that also returns false. And we now come down to this line here, number 28, okay, and we say if target, okay, is less than our middle position, so is the value 12 less than 7? So is our target 12 less than 7? No, it's not. Okay, so we need to come to this statement here. If target is greater than array middle, now we are looking in this area here. Okay, so we start here. Now let's plug in our array again. Why not? Hey. Okay, sorry if my shorthand is not that clear. But essentially we start off with our array again. Okay, let's just do it one time, make it look a bit neater. Our array target is the same value. We are now looking, array is greater than 7, so we are looking from position 1, so middle plus 1, so that's going to be 0, 1, 2. Okay, and you can just check it the way I just did, and our endpoint is going to be this point here. Okay, because if you recall what it was previously. Okay, so now we've plugged in all our values, and again we run our values through the checking system. So start plus end, so 2 plus 3. Okay, 2 plus 3 is 5. 5 divided by 2, again we're doing integer arithmetic, it's going to give us 2. Okay, and now when we come here, we say 0, 1, 2, and we say is number 12, okay, the same as our target, and this time we know that it is true. So immediately we return the middle position, okay, and the middle position being 0, 1, 2. So we return the value position 2, okay, so this will return 2. Now if we run our code, you will see it returns the string. Okay, one moment. File, project properties, run. Okay, I'm just reconfiguring my run here. Browse for the main class, recursive binary search, select main class, okay. And if we just run that again. Okay, so 12 was found at index 2 as we said. So that's perfect, excellent. So we just covered the recursive binary search, and the final one we're going to review is the recursive merge sort, and then we are finished. I hope that was helpful for you. I'll provide a link to the code also, and as you can see, all my comments are available for you to review for yourself. Thank you.